So come on up, Chris, and tell us about space domain awareness and astronomy.
The arrow keys.
Yeah.
Okay. Cool. Yeah. So I'm going to switch gears a little bit. Not so much. Oh, thanks. Not so much on the AI/ML, although my company does do a lot of that. You'll notice. So I'm going to talk a lot about space domain awareness and like the aerospace company, like sort of landscape in general. My company's one of the older aerospace companies. That's why it's called the Aerospace Corporation. We were the first one, I guess. So we just picked that as our name. But we have a lot of data, right? Like we have tons of satellite data from early missions, from later missions, all kinds of fun, like lots of good data for a lot of these AI/ML problems. And so what I've noticed at my company is shifting is we are using the same tools that's been talked about this whole time. But what really sets us apart is having a lot of that really good truth data to train these algorithms. And so it's a really exciting time in our company, actually, as you'll see, my group does a lot of modeling. So coming up with really good model data that we could use to train stuff, and using that physics base is what I see is crucial for this community in terms of utilizing these tools. So that's where I see like a lot of astronomers, physicists, in general, where you really set yourself apart. We get a lot of resumes from generic data scientists, that, you can get degrees in that now, right? But as someone who has a really solid physics background, I really think that sets you apart. So just some word of, that's something that my company certainly looks for, my group looks for. So just wanted to say that. Well, no, sure. Yeah,
The focus issue. So there we go.
Sweet, thank you. So my career path. So I was also an undergrad at Berkeley. That's where I met the illustrious Jeff Silverman over here. He's basically the only reason that this exists, by the way. So thank him. So that was a long time ago, where we did a lot of observing in the basement of Campbell Hall. So that was, yeah, I did a lot of supernova observations, sort of, undergrad, you're kind of just getting your feet wet on research and sort of getting yourself set up for grad school. I then went to Penn State and I did X-ray instrumentation. So I did a lot of lab work, which is generally, not the norm in this community. But I did a lot of, learned a lot about instrumentation, detectors, that sort of thing. And then I went to the U.S. Naval Research Laboratory, and that's where I sort of got my feet wet in the DoD world. They have resident astronomers there, a lot of X-ray folks in the high energy space environment branch. So that was really where I got my feet wet in terms of that. But it was a nice transition in terms of it still being academic. And then I jumped over to the Aerospace Corporation where I've been since 2017. I was started in Chantilly, Virginia, which is outside of DC, at the office there. And then I've since moved to Albuquerque in the same company and actually the same group. So I'm a member of it's called the Sensor Modeling and Simulations Department. And so a lot of what we do is create model data to test. Basically, the government's trying to fly a sensor in space or on the ground. And they want to know if it's going to work correctly before, they build it. So a lot of modeling in terms of optics, detectors. You'll see a lot of the stuff I do for space domain awareness in terms of tracking satellites. But mainly my group is really embedded into creating really good physics-based data. And so we partner very closely with a lot of our AI/ML groups, machine learning, that sort of thing, to give them data to train things. Or if the contractor comes to the government and says, hey, I have this amazing algorithm, that does X, Y, and Z. We can test it with our data that's been vetted based on, all of our physics background and things like that. So it's a really fun company in terms of working with a lot of different disciplines, a lot of engineers, thermal, mechanical, all the things that would take to build a satellite, right? But here we are in my group where there's quite a bit of astronomers, but there's also a lot of physicists, optics engineers, that sort of thing. But we partner with them very closely. And we have a lot of labs on the West Coast as well, where we can test things, use that data in our models to make it even better. So it's a really fun job. I like it. I get to work with a lot of really, really awesome people, and it's very academic. It's not, we're sort of a nonprofit. And so we're not, profit motivated. So it's, the pressure isn't, as high. So. Okay, I'll just dive a little bit into space domain awareness. Again, the company Aerospace works on tons of different problems, and I'll sort of highlight that a little bit later, but I'm happy to talk with anyone about all the different types of really fun stuff that we do. So I've sort of talked about this, I think, 2 years ago when we were in New Orleans. So space is crowded, right? We all know that SpaceX and other companies like Blue Origin have made the cost of space small as comparison to before, right? And so satellites get deployed and tens at a time in terms of this with 60 Starlink satellites. And they're almost disposable at this point, just because access to space is so cheap. So we're able to do things like build cheap satellites and have them fly for a couple of years and then burn up when they come back. So again, it's sort of changed the game, right? We aren't building as these sort of Cadillac satellites like we used to in terms of them being pristine and are going to last 20 years. When it comes to LEO, which is low Earth orbit, things can be disposable and that's okay. But when that comes, what that's doing is causing us the problem in terms of tracking satellites, making sure they don't hit each other, things that's normally in the Air Force's job jar a lot harder, just because things are getting deployed very quickly, and we need to quickly figure out, okay, are these things going to be okay? Is there anything in the way? Is it going to hit the ISS, which is a giant bus, right? Like that, you can think of that as like everything's like a tiny toy car, and that thing is literally a bus in space. Like it's just so much bigger than anything else. It's just making the problem much bigger. And so we need a lot more data, and we need a lot quicker ways to be able to analyze it. And so that's where all of these problems come into play in terms of us providing model data, us developing algorithms, working with all of these customers to figure out what's the best way to do this. I think that's all I wanted to say here. So I'll talk a little bit about the community. So it is a big community. It's much like, AAS, astronomers. There's a lot of big players in the SDA community. So SDA, Space Domain Awareness. AFRL is a big one in terms of the government. It's the Air Force Research Laboratory. So that's a very academic institution that the Air Force has set up, hires a lot of PhDs to look at problems like this and others. There's a lot of commercial getting involved, right? So it makes sense that the government just can't keep up with building its own sensors. So what does it do? It puts it out to industry to figure it out for itself, right? So Exoanalytic is a big one. They basically are deploying tiny optical telescopes across the world to basically sell data to the government. So they're using special techniques in terms of understanding a lot of the problems that astronomers are doing, right? In terms of detecting streaks and dots and trying to figure out, okay, where's this target going to be in 10 days from now, and making sure things don't hit it. And so all this to say is, and then we also have some academia in terms of the University of Arizona has what's called a Space Force Center, which they use a lot of the same mountains and telescopes that are being used in astronomy, but for different purposes in terms of tracking satellites. So they're doing a lot of really cool stuff down there as well. And so again, we're getting a lot of data, which is great, right? We're getting better at deploying these smaller-ish telescopes to track satellites. Fusing it is certainly an issue in terms of figuring out how to get it all in one place so we can make decisions. And so that's where a lot of these data-driven problems and solutions can really make an impact. So again, aerospace does a lot of this, but there's a lot of other players in it, and I encourage you folks to check out like who's doing research in it. Does it sound cool? And see what's out there for you. In terms of SDA conferences, so the big one, so yeah, just again, it's a community, right? And it does feel very academic in some respects. So the big one is going to be the AMOS conference. It's in Maui every single year, Advanced Maui Optical and Space Surveillance Technologies Conference. It's well attended because it's in Maui, so that's fun. But their conference proceedings are free online. And it gives you a nice idea of sort of what problems folks are looking at in terms of in academia, at places, in industry as well. So a lot of contractors will go here to talk about their new techniques that they've developed to try to sell to the government, or sensors, or all kinds of cool stuff. So it's a good place where you can get a sense of what's going on in the community, and gives you a sense of the sort of academic nature of it. I mean, it's a fun conference. Obviously, it's in Hawaii, so that's cool, but it's a good place for industry, government, academia to all sort of commingle and figure out where we go next in this community. There's other smaller conferences as well, but just giving you a sense of this is a whole community out there that is doing really cool stuff and needs astronomers, in my opinion, because you guys have, again, that physics background, the astronomy background, and understand this problem space, which is basically, again, you have an optical telescope, you're trying to track something and then determine sort of where it's going to be in the future. So I'll just dive into this paper, which I published not this past Amos, but 2 Amoses ago, about our scene simulator that we developed. So I'll go move on to that. Good, it's working. Yeah. Okay. Where to start? So this is something that my group developed, right? So again, a lot of sensors are being developed, a lot of algorithms are being developed in terms of trying to make this problem easier in terms of being able to track things and determine where things are going to be. And so what we did is basically three of us, we were all astronomers in the same group, basically developed a high fidelity space domain awareness scene simulator. So basically what it's doing is it's basically simulating images as seen from a sensor tracking a target with the background stars streaking, all that kind of stuff. And then you can see we've also added bias. There's dead pixels in there as well to try to, again, make as accurate as we can, data that can be fed to image processing algorithms to ensure that they're going to work correctly on orbit. So starting at the top, we have this sort of circle here into our main tool. It's called TradeX. It's sort of an acronym. I won't say it. But we have things like sky backgrounds, so things that the zodiacal light, galactic plane, things that are noise, that you don't want in your image, but obviously what happened there. And then we're going to have optics and baffle design. So we're going to get things like stray light, or if you're looking close to the Earth, you might get stray light from the Earth into the baffle, and you'll see some of that a little bit later. We have the target characteristics. We can do 3D CAD models or just simple diffuse spheres, and then sensor parameters. So things that you're well aware of in terms of how fast can it slew, what is its elevation limits, and then when it comes to space sensors, sort of what orbit it is in, et cetera. So in this case, at the bottom here, you can see the cyan is actually the orbit of the sensor, which is in a geo orbit that's inclined, and it's rate tracking the zero inclined geo target there, which is that center dot that you're seeing on the right there. So basically the telescope is doing its best job to basically keep that centered on a single pixel. And then that target streaking down from the top to the bottom is going to be that really high inclined target. That's basically your bonus as it streaks through the field of view. So I'll go into a couple of details about how we did this, but just gives you an idea of some of the cool problems out there in terms of using astronomy and trying to build really good data, simulated data to test some of these algorithms and basically give the government, validated answers as to if it's going to work on orbit. So here's just some things we did in the scene simulator, which is kind of fun. Pixel phasing, obviously we wanted to get that right because whether you land on the center of the pixel or a corner, things are going to look very differently on the focal plane. In the ConOps there, you can see, we can just change those based on you're doing rate track like what you saw earlier, or you're doing a sidereal stare where you're staring at the stars and the target's going to streak through. But yeah, some of this might look familiar. Like we use the Gaia DR2 catalog basically to tell us, where every star is, what its color was, how bright it is, and getting that correct. We collaborated with some of our optics SMEs to get a PSF to account for the pixel phasing. So that's basically redone at every single sensor that we want to model. Color corrections, if you remember that from undergrad. That was fun. Still hard. Yeah, I always do it wrong. But yeah, since we had the red and blue from the Gaia catalog, we could actually do some really fun color corrections so that we knew a red star is going to look brighter in this band versus this band, things like that most industry is not going to do. So things that we could use our astronomy depth to really get right. And then background sources as I talked about, and then cosmic rays, and you'll see some of that next. Yeah. So here's basically a full up image here that we put in our paper. You can see there's like a gradient from the right to the left, and that's because in this observation, the sensor is actually staring near the limb of the Earth that was lit by the sun. So you're actually seeing that gradient across, which happens in real life when you're staring either near the sun or the moon or something like that, which can be hard to get rid of because of the gradient. So it's a good test for some image processing algorithms. In this cyan, you can see the cosmic rays there, and then the green are actually the targets. So that's the whole name of the game, is basically trying to say, oh, I found 4 targets. They're at this specific RA deck at this time. Can I use that to determine where they're going to be in the future? So it's a lot of finding the dots versus the streaks. And so again, you could imagine how many folks out there are trying to throw AI/ML algorithms at this to say, okay, find all the targets in this. Or just simple image processing algorithms again to to try to either find the very faint targets or make sure that you don't miss any. How many false positives are you going to have, right? So these are all tests that we do using this data to validate, contractor algorithms or internal algorithms to make sure that we don't miss anything, basically. Yeah, so yeah, and sort of just the thesis here, right, is we try to make our data as realistic as possible, because what we see a lot, and I'm sure it's, it's everywhere in a lot of other communities, is they're like, oh, we found all the targets, but their data will be super clean, won't have cosmic rays, it won't have bad pixels. So we really want to get things right, because if they say, oh, we can do this on orbit, and then they start getting images like this, where you actually have, dead rows, dead, things that happen on focal planes, that we can actually get that data from our labs too, so we can imprint the exact, read noise distribution and things like that, to make sure that those algorithms are going to work with realistic data. Yeah, so just a summary of this part, and I'll jump a little bit into sort of what aerospace does more too. But again, we definitely need astronomers in the SDA community, whether that's at aerospace or other places. This is a growing field. There's a lot more players in it now that, space is more crowded. There's a lot more countries launching things. So it's nice to have physicists and astronomers with that background to understand this problem, and having experience with, either observing or doing data reduction and things like that. It really sets you apart, in my opinion. Again, the skills to make an immediate impact. So yeah, I encourage you to talk with me or look at some of the Amos papers in terms of what people are looking at. Again, it's a lot of the same problems that others are looking at in terms of characterization, AIML, cislunar types of stuff, which is a fun regime in terms of things being orbited around the moon. So lots of really cool problems out there in this. And there's other ones too, just even within my group. So other folks in my group do geospatial imaging. We also do object tracking, hyperspectral imaging as well. I did put a couple recs out that are a little specific, but the hyperspectral is certainly an area we're looking to grow. Just throwing this up there, I got this from my company, just showing you sort of the breadth of what aerospace is. And you're going to find this at most aerospace companies as well, in terms of, large contractors like Northrop Grumman or Lockheed. But basically, you can see I'm sort of over here on the left in electronics and sensors, where we're doing optical sensor modeling, sensor engineering exploitation. But as you go over, you can see you have data science, you have mod and sim and the systems engineering, vehicles, right? So you have propulsion, thermal control, all kinds of really fun things to study and work with people in. So it really is like a university in within itself, just given the number of disciplines that we have employed. So it's pretty fun to, have a thermal question and be able to call a thermal SME and figure it out and build teams to really solve these really complicated problems when you're trying to build a satellite. And then, yeah, so this is sort of another thing I stole from my company, but that's my email at the bottom. I did post a couple postings up. We are starting to hire again. We weren't completely immune to all the weirdness that happened this year. But we are starting to trickle in more recs are starting to come out in the new year. So good news there. And again, reach out to me. I'm happy to answer any questions. Yeah, that's my aero.org email. It's a large company. We're in our two biggest offices are DC and LA, but we have also one in Colorado Springs and Albuquerque, which is where I am, and then a few other smaller places across the country. Yeah, I think that's all I got. Well, thanks. Yeah.
Got time for a few questions? Thank you, those were really interesting. I'm curious, how often are you imaging the whole sky? Or is it just done on a target basis, or you sort of just play the?
Yeah, there's usually, so yeah, great question. So we asked if, I think everyone can hear it, but how often are we imaging the whole sky? So yeah, so if you look at like some of that U of A work that I was talking about, they build sensors that have multiple of them, and they constantly just look at the geo belt like all night. So again, another very big data problem like we saw with LSST, where basically, yeah, you're taking an image of the geo belt every minute or so, and then there's other ones that'll just like scan the sky as well. So it really just depends on the ConOp. And then if you're really interested in something, yeah, you can always do a direct follow-up. So there's different types of sensors. But in general, like the things that get published every single day, which are called TLEs, those are generally from pretty large sensors that just scan the sky and then just update those on a daily basis, basically.
Cool.
Mhm.
Hi, thanks for that great talk. My name is Zach. I was just wondering, a lot of these techniques seem like they would be applicable to near asteroids as well.
Mhm.
Do you track those as well?
So we don't, but there are certainly groups at JPL that do, like they are very, that's like their thing is looking for asteroids. And they've developed some very similar techniques where they're, because it's, again, it's reflecting sun, right? That's how you find them. They're a little different in that asteroids can come from like way different orbits and different types of things, but yeah, we certainly collaborate with them as it's a very similar problem space. So yeah.
Awesome, thank you.
Mhm.
Down in left field a little bit,
Sure.
but recently there was a spate of articles saying that basically that Elon Musk and Jeff Bezos of the world want to put AI data centers in space.
Okay.
Is there any of the deeming? I just can think of nothing. Like, why on earth do you want to do that? Is that a thing that would destroy our ability to look outward, etc.?
That seems, that's the first time hearing of that, so this is off the cuff, but power in space is generally pretty hard to get. So I don't quite understand that. And then data, I mean, so a lot of the SDA problem, right, is it's a data problem where sending down a 2K by 2K image is expensive. And so a lot of what we want to do, right, is do a lot of onboard processing. And so I don't quite get the idea of like having, yeah, because data, the pipes, it gets expensive, depending on how much bandwidth you have, right? How many ground-based things are looking at you when you do your data downlink. So I'm not sure the angle there.
But I thought, I think one, those are all good reasons not to do it. I think one of the reasons to do it was cooling. You don't have
Sure.
to pay for air conditioning, giant warehouse in the middle of the desert. You just let it sit in lower orbit. But for all those other reasons, it's a terrible idea.
Yeah.
But yeah.
And cool. So I work with thermal analysts, and it's not as easy to cool a satellite as you think. I mean, I don't know. I guess you could build it with like just like 3/4 of it are just radiators. Yeah.
that's the idea.
Yeah. But still, even then, it's tough, especially. I don't know where he wants to put them, but if you have long eclipses and things like that where you don't get power, it's yeah. I've learned a lot with this job, and cooling a satellite it's a tough game. So
Other questions for Chris?
Hi, thank you for talking. My name is Katie. I'm an undergraduate student, and so I'm curious what the day-to-day looks like for you in your position.
sure.
Just to learn more about it.
Yeah, absolutely. Okay. I'll start from what I did like when I was like fresh out. Because you know, as you get older, you get more management stuff maybe, or write more emails. But yeah, so I did. So a big project I worked on was that data, the scene simulator, right? So it was a lot of coding. We were using a legacy code base, but it's C++. But I didn't know a lick of C++ before I started. So so it's a lot of coding, and it's a lot of what I do now and what I did before is storytelling. I think someone talked about that earlier, is a lot of the people we end up briefing or talking to are not technically, don't have PhDs. So writing briefs and for giving a good message of like why they should do X versus Y is something I do a lot. But day to day, yeah, it's a lot of meetings, a lot of building teams, and then a lot of, yeah, just doing analysis, whether that's coding or running some of our tools, like creating data or learning new tools, things like that. Sorry, this is pretty generic, but yeah, it's a lot of teams meetings, things like that. And just, yeah, building teams, I think, is what I do most lately. But to start out, it was very technical. I was actually surprised when I started how technical it was. I was, compared to my postdoc, I was in the weeds building the scene simulator, which required a lot of coding, a lot of physics, a lot of, validation, things like that. And then also presenting it to the customer at the same time. So again, narrowing down that message to show them this product. So yeah, happy to talk more too. So, sure.
One more quick question? Maybe online, Eric? No. So, always checking in with her.
All right, let's thank Chris again.
Thanks, guys.
Right, and our final speaker today is Eva Noyola, another longtime ATDS participant, former co-organizer of the meeting. And so I will stop sharing. And Eva, if you want to go ahead and take it away.
I think I took over. Can people see the slide?
Yeah, we got it now.
Okay. I cannot see you people, so
You
please
should be
say
able to
something
see
if
my
there's an
name
issue.
here.
Oh my God, I guess is the way I have this thing. Anyway,
Oh, now I
Oh.
no, hold on. I'm trying to be cute.
Yeah,
I messed it up.
now I think I may. Yeah, now I see you. Okay.
Well, we need to see your screen, so
Oh,
there we go. All right,
okay.
we're good on our side.
Thank you. But I moved the slide. Oh well. What? Why can I? Okay, there you go. Thank you so much for having me. It's fun to be here in the presenter seat instead of the organizer seat, which I have done for the last couple years. So I appreciate the switch of scenery in that sense. I come today to try to evangelize people that working with data positions in the public sector, in government positions or any other public sector, is not necessarily terrible. So it's the story of what do I do as a data bureaucrat. So first I'm gonna start with my origin story. I studied physics as an undergraduate in Mexico City at UNAM. And then from there I came here to Austin to do grad school in the astronomy department. I'm so happy to see several graduates from that department here today, some of which I actually share my time with. Julia in particular, we started at the same time and had the same advisors, so we're really close with Andrea. I also spent a fair amount of time, so that's fun. What I did in my graduate time, I was an observational dynamicist. I focused most of my work in globular clusters. So I used to observe the internal dynamics of the center of globular clusters. That was most of what I did. So after that, after I graduated, I went to MPE in Garching, Germany, for a long postdoc, actually, where I had a fabulous time because, having access to the ESO telescope and the MPE money makes for a very nice combination. So I was very happy doing science there during those years. Then I did a still decent sized postdoc, but a shorter postdoc at UNAM, which was my original alma mater in the Astronomy Institute there. But after that, I ended up being called back here to Texas to work for the McDonald Observatory, in which I continue doing my science, but I also work in a big instrument project, virus. I had to work hands-on in a lab at that time. So in the end, it ended up being a well-rounded astronomy career in which I did mostly observational stuff, but a little bit of instrumentation too. But because I wasn't soft money, eventually I decided to jump to a data position because it's not very sustainable these days, living on soft money. And through this story, you might have noticed that there was this, I keep having this loop between Mexico, Texas, and Germany. But anyway, I ended up, I may just stick in Texas this time around. So knowing that I wanted to stay in Austin, my first data job was for a startup called Zen Business. And I did get that job as a referral from another UT graduate, a fellow UT graduate. So that is very common for a lot of people, that the first position you get is through a referral. And after that, there was a layoff in that company because startups and the times and all of that. So it was very hard to get a job these days. A bunch of people in this group in astronomy, astronomers turned data scientists, were super nice in that era when I was looking for jobs. They gave me referrals, but people were really, really not hiring in the private sector much. So I ended up turning my eye to the public sector, and because I live in the capital of my state and my state is pretty big, there were plenty of things to try for. So that's how I ended up working for the controller of public accounts in Texas. And that's where I've been the last 2.5 years. So from my brief stay in the private sector, I don't regret having done that for a little bit. I will say that a lot of the story that I'm about to tell has a caveat that this was, like I said, a startup, and that I entered it when they were on a hiring spree. They were expanding really rapidly. So startups are already a bit chaotic. This made them even more chaotic because, when you just hire a bunch of fresh people and there's more ideas and resources. Oh, cat. Ignore the cat. So part of the reason, at least with this startup, I don't know that every startup is like that, but this one was like that the grand vision, the grand vision of things change every few months. So every time you thought you were understanding where things were going and you were building stuff for that, to serve the company and all of this, suddenly big change. This thing that we were working on is no longer the thing. We need to focus on this other thing. And, that was a little disorienting, but also it taught me a lot very quickly because they were introducing new platforms and systems all the time or a lot of the time. So you had to jump in quickly and understand this new thing and learn how to work with it and learn how to get results out of it. So it made for very quick learning. It is a very fast pace, which, it's a matter of cup of tea. Some people like it like that. It can be tiring at sometimes. At some point, you're like, can I just sit down and work and just develop things quietly for a little bit? And there was not a lot of time or space to do that there. I had mostly great colleagues, but just to illustrate what happens in this quick pace situation, of the 11 people that were in the data science group when I was working there, there's one left today. So the good thing is that I'm still friends with many of them, and it was a very good networking exercise, and I really appreciate what I learned there, but you cannot count on it being a place where you are going to stay for a while in these startups, not necessarily. I got to practice a lot of context switching, which, it is an ability that is better to have than not to have, even if it's not super pleasant to learn. So that was one advantage. And that my time there became really the time when I learned to use SQL as a pro. That was the weapon of choice for most things. So that gave me a very good foundation to really access databases comfortably with SQL. So once I went back to the public sector, this I wrote as a caveat. I don't know if it should be a caveat, but my agency, for some reason, is one of the top-rated agencies to work for in my state. I don't know if it's a matter of luck or historical reasons, the fact that it's relatively technical. I don't know what it is, but people are pretty happy to work there. So this may not extend to every other public agency or space, and some other people may be quite miserable working where they are, but in this particular case, I got lucky, and I landed in one where there seems to be general contentment with the work. So it's such a different beast, to work in this in this type of situations, because in this case, they have very conservative setups for your training and your onboarding and your learning and all of this, to the point that sometimes you are actually ready to do things and they want you to wait. In my case, they let me get to do production, stuff quickly enough. But I've seen some other people pretty eager to get started in real work and still having to go through the training, to the official training times. Many of my colleagues have been there for decades, which at least sounds like it's not a place that people run away from. And I think that's relatively common in public service. There are probably several reasons for that, but it is comfortable in that sense. Nobody's running around like a maniac. There's not that much turnaround. One thing that, again, it may be different in different agencies, but in mine, they will have most likely very ancient platforms and or systems. In my case, the example that I can give is they still use a mainframe to access some of the databases. Mainframes are very slick. They're very, not slick, but they're very quick because they were set up a long time ago. They were very efficient. A lot of the programming is done in SAS, which is an old programming language. I haven't quite learned it because they are trying to kill the mainframe in the coming years, so it was not worth really learning it. But I know enough of programming. You can at least read the programs and do small modifications there. They transport stuff with, I have to transport stuff using FTP, for example. It really makes me remember my days back when we used Pine to read email. And I don't know if the audience in this talk is old enough to understand any of what I'm saying, but I can see how a young person that just graduated comes there and they have to learn this stuff. It can be quite a shock. It's not what they were taught in school. It's really old stuff. The one advantage is that because things are conservative and they need to be very reliable, the databases are very well established. So at least you're not like really, it's not a wild place. It's not a lot of dirty data. There's not a lot of cleaning that you have to do because, this is delicate data. The reason why I cannot show you any actual figures or actual results is because obviously all the data that I handle is very, very sensitive because it is essentially all the public money in Texas and going through agencies. So it's a lot of money and it's not something that we can show. One thing that I've been trying to do, because there are a lot of these old systems, is renew, essentially, try to renovate processes. So I'm trying to port a bunch of the stuff that has been done in this mainframe, trying to port it to like SQL things that are easier and a lot quicker to run. That said, people that have been there for a while, they like the way they do things. They don't necessarily need to do things differently. So adopting new ways to do things, it takes a while, and you need to very slowly convince people to, move on to the next set of tools or ways to do things. So it's been working. Some people do it quicker than others, but it's one of the things that I've been spending some time doing. Because of this reason, there's a fair amount of room to make your mark because there's a lot to work with. if there are systems that can be improved, then you have a lot of the tools to actually do that, improve processes and show people that there are nicer, prettier, quicker ways to do things. So I found that it's been good to know that people are happy when you improve a process or some of the reporting. Also, this year I joined. There's an internal program for mentoring, and you can mentor anybody in the agency. And as soon as I put data as part of the description of my job or what I do, I got rained on essentially for people that wanted to be mentored. So that's been also very nice because it shows that some people really want to modernize a little bit or even learn a little bit. So I have a wide range. Somebody who is actively studying data stuff, to a lady that wants to learn how to use some tools, to a lady that really wants to be comfortable around Excel, literally. So there's a wide range in which you can make a difference talking to people. So that's what I wanted to say. One person that knows technical knowledge can make a big difference in a place like that. And one thing that I was not expecting, I swear, there are heavy days of work like everywhere, but I don't stress. I don't stress about things. I don't think about things. I don't bring them home with me. They don't take up my sleep time. I didn't know that was possible, and yet it is. So there's that. So the possible downsides of working for the public sector is that any innovation, if you're in a hurry to learn a lot or create new cutting edge processes, things, products, that it's going to be hard. There may be places where they need it and they need new stuff very quickly, but for the most part, the processes are very conservative. The changes are very slow. They need to be quadruply checked. So any innovation will take some amount of time. The salaries are in general, as we all know, lower in the public sector than in the private sector. I do believe that gets compensated with the benefits, but it's a matter of so just the salary itself is not the main number that one has to look at, but they are lower salaries, that's for sure. The setups are very rigid, as I said, so you need to really have patience to try to move things along. Politics might play a role because most times the head of these agencies are either elected or appointed by the local government. So sometimes, there can be, if a government changes parties, for example, it can be a big thing to deal with. In my agency, because it's quite technical, that's felt a lot less, but I can see how that could be an issue for other places. And there are learning opportunities, definitely. They do like to support people learning and improving whatever their baseline formation is. So like for a young person working in the public sector could allow them to I don't know, do a new master's or take some training classes and things like that. But it takes time. They also are not in a hurry to let you do that a lot of the time, so you need to take it easy and pace yourself. So the learning opportunities may be slower, but they're definitely there. And now, just to close, I want to talk to you about the possible upsides of the public sector as I have seen them. The benefits, when I say that the benefits are very good, I really mean it, in the sense that the retirement programs are pretty good. They're pretty generous and pretty safe. Again, because they're pretty big, they normally negotiate deals for an entire state or an entire county or things like that. So they're pretty good. So it's not only the typical health benefits or the retirement, but there's also a lot of little things on the side that you rarely, not always see in the public sector, some of them. What happens to you with disability insurance and all of that stuff. Those are very good. The job security generally is very good unless you're in a position that, like I said, is very dependent on elections. If you're in more technical roles, for the most part, your job is pretty safe. After those years when I was part of a layoff and I saw so many of my friends go through that or turn around between jobs, it's nice to know that I don't need to worry about that for now. I said pass as a wizard in the sense that if you have technical knowledge and you arrive at a place where people that have been there for a long time, I literally have been called a wizard multiple times since I started working there, because there are relatively solutions that for us are relatively simple and are very obvious. They are not obvious for the people there. So I've been able to help not only people in my unit, but in people next door. And they are really very grateful because they were stuck. They couldn't figure out a problem, and you came and you found a good solution for it. So that is a nice reward, I would say. Like I said, much less stress. Because in the pandemic, some agencies already were doing hybrid work before the pandemic, but since the pandemic, they all had to implement it. And whether they like it or not, it's been very hard to get people back to full time in the office. So the vast majority of the places that I know of have either fully remote or at least hybrid work. I work in the office 2 days a week, and the rest of the time I work at home. So that is a really nice perk. That makes for a much more flexible schedule, for my kids in school and stuff like that. There's lots of room for innovation in a place like that because, again, you're coming very well prepared to a place where there's less of that. So there's always a lot of ideas that are going to be well received and you can implement. There's a good chance of making big impacts for that reason. And because these systems are very well settled, your schedule is very predictable in that sense. In my case, because I work with auditors, every quarter I know what's coming roughly. It's a relatively stable. So I know what extra time I have to do the other stuff that I want to do, besides the basic work that comes every quarter. So that I found very soothing. I don't know. I like to know that I will have time to do my own stuff. And the other thing that I didn't think about, but it's actually nothing, is that most of public organizations, the employee systems of these public organizations very often have unions, which, it does offer some extra job protection. So that's something that it's an advantage that some others may not think about. And I think with this, I am done. So I have enough time for questions, or I can let you go into the afternoon and enjoy yourselves.
Thank you.
Let me know if you have any questions.
Questions?
I know you can't say like super specific things, but can you talk about a little bit about sort of the problems that you're working on with Texas? Just curious, like unemployment, or is there a specific division that you're in? Just curious, sort of what sort of problems you're working on for the state.
Can somebody repeat that? I got Texas and unemployment and problems, but I'm not sure I got the exact question.
Yeah, sorry. Just what sort of problems you're working on for the state, just in general, like, how are you helping the state, like, for your data science stuff? Just, in general.
So most of the positions will be called data analysts, actually, in the state. There does exist the figure of data scientist, but those are rare. I guess those are a very, very specific type of project. Most people will be called data analysts officially. So that's the other thing that I should clarify. If you see a data analyst position advertised, don't take it as a boring, just like move things from Excel on one side to the other, right? For example, in my private sector job, I never got to use Python. Whereas in this one, I recently started using it, and it's making a huge difference, for the project that I'm doing. And people are pretty happy with the fact that things can be done quickly and efficiently, and you can handle a large volume of data and do sophisticated things because I'm using Python. So even if the job position may say data analyst, and you don't see positions as a data scientist, it's worth looking into them and asking about the details, because most of them will be, they're not dull data analyst positions. Many of them have a lot of analysis and prediction and many things that are interesting to us. I don't know if that answered your question.
Other questions? So I've got a question, Eva. You talked a lot about, people been there for a long time, legacy systems. You're a wizard, you're bringing in new systems. How do you deal with people who like the old ways and don't want the new wizard systems?
So I, in my group, have instituted a carrot and, no, not really stick system, more of a carrot system, in that, for example, they don't visualize data, they don't like visualizing data or anything like that. They like their own Excels. But some people are curious about that. So I ended up bringing dashboards, for example, and I put a little bit more information that could be useful for some of them in the dashboards that are not in the Excels, right? Or that would be very clunky to have in the Excels. So the ones that are willing to get the novelty, they actually, the other problem is, if you want the dashboard, in this case is Power BI, because we're Windows based, it takes about a week for IT to give you the program if you ask for it. So they forget, and then I have to walk them to how to order it. But once they have it, they actually like it and they enjoy it and they start using it. So it takes a while. And with other things, it's like that. For example, the people in the other group that needed help, the lady that needed this particular report, she really, really, really wanted to learn how to use it and do it herself. But it required knowing SQL. And if you don't know SQL, you cannot troubleshoot in the thing when you're running it. And at some point, they came to terms with the fact that, it was much quicker and much more efficient if we just produced a report for them and gave it to them, because they didn't have time to sit down and learn SQL. But at least now they understand that there's a value in knowing how to query the databases. And they, again, or if they're willing to put in the time, then they may learn actually how to do queries themselves. So it depends. It depends on the people that you're working with. Some things take more longer than others. But you know, if you come up with solutions, often it's people will like it. I don't know that I can, for example, sit down and make somebody learn Python anytime soon. But maybe if a new analyst come, a younger person, they may want to do it. In my whole floor, I think there's like 3 or 4 of us that use Python, so at least we can talk amongst ourselves. So yeah, I mean, you just need to learn to navigate the situation. I don't know if that's what you wanted to know.
Yeah, thank you. Other questions for Eva? All right, let's thank her one more time.